Good evening. This is the April 27th assignment for College Algebra Unit 4, Section 2b, problems 12 through 22. Notice our first polynomial, and it's got to be polynomials for this to work, meaning no fractional exponents or anything. 8x cubed minus 4x squared minus 20x plus 12. We have two sign changes, from positive to negative, and then from negative to positive, two sign changes, so two positive roots. Then I put 12 over 8 to find all of the factors. Up on top are all the factors of 12, on the bottom all the factors of 8, and those combinations are the possible roots. First I try 1. 1 with synthetic division doesn't come out to 0 on the end, so it does not work. So I try 1/2 on this, and it comes out to 2, does not work. So I try 3/2. 3/2 does work. I'm left with, remember you want to go from what's left if you find one that works, 8x squared plus 8x minus 8, and I can take an 8 out of that as a common factor, then use the Pythagorean theorem to finish up to find the other two roots. Number 13 is this problem. Now number 14. No sign changes. X to the fourth plus 8x cubed plus 21x squared plus 22x plus 8. No sign changes. So no positive roots. That means all of them are negative. Then I put my mistake here. I put 8. I was looking at the previous problem, and it happened to be that I came across the right answer, but I put 8 over 1, this 8 over the 1, the factors of 8, all of the factors of 8 over the factors of 1, but only negative ones. So I tried -1 first, and I found that it worked. It left me with 1x cubed plus 7x squared plus 14x plus 8, and I do use it. I don't go back to the original. Once I find a root, now I've got to use this. I cannot use quadratic formula or factoring on this. So I try -1 again. That's a good thing to policy to do, because sometimes that -1, for instance, can be what we call a double root. And when I use it on this new polynomial, I find that it does work. 1x squared plus 6x plus 8 is left, and then I factor it, and I have -4, -2. Remember, up here at the beginning, these numbers I had down were wrong. I needed to put 8 over 1, the possible factors of 8 over 1. Then number 16 is here. Notice I have 4 sign changes. So all of my roots are going to be positive, and I put 6 over 12, all the possible factors of 6 over all the possible factors of 12, and all of their combinations. I like to start close to 1 and with small numbers to see if they work. 1 with synthetic division came out to 2 on the end, did not work. So I tried 1/2. 1/2 gave me 0, so 1/2 worked. Now I'm going to use 12, -46, 50, and -12. I try 1/2 again on these new numbers to see if it's a double root. Does not come out to 0 this time, so 1/2 was not a double root. So I go on and now try 3/2 on my new group of numbers here. And it does come out to 0, so 12x squared minus 28x plus 8. Always look for a common factor. 4 comes out of that, leaves me this. And you could either use a quadratic formula, or as I did, factoring. So I get 1/3 and +2 as my other two roots. Then problem 17 is here. I did not work it. Then problem 18, notice no sign changes. So all of my roots are going to be negative. And I put 12 over 18 and all of the possibilities here, all of those combinations, 12 over 1, 12 over 2, and so on. All of those are possible rational roots. But I'm not going to start out with the big numbers. I'm going to start out with small numbers. -1, I go through with synthetic division, gives me 0. So now I'm going to use this new group of numbers, 18, 51, 44, and 12. I try -1 again to see if it's a double root. Does not come out to 0 on these new numbers, so it's not a double root. Then I go to -2/3 just by accident here, and it does work. So now I've got 2 of my roots, and I am left with 18, 39, and 18, giving me this new polynomial. Take out your common factor, and I have this new group of numbers. You could either use a quadratic formula, or as I did, factor it, and then these are my other 2 roots besides the 2 I already had. Number 19 is here. 20. We have this, 1 sign change, 2 sign changes, 3 sign changes. So 3 positive roots and 1 negative. I put 1 over 6. All the possible factors of 1, which is 1 and -1, over 6, 3, and 2. So 1/6, 1/3, 1/2, 1, or -1/6, -1/3, -1/2, -1 are the possibilities. I try 1 first. Notice it doesn't come out to 0. Did not work. Then I try 1/2. Sometimes you got to work quite a while to find which number works. But 1/2 through here gives me 0 at the end, so it did work. So now I'm left with this, 6, 10, -10, and 2. I'm going to take and use these numbers again. I'm going to take a 2 out of all of these as a common factor. So now I'm going to use 3, 5, -5, 3, 5, -5, and 1 from these numbers because I factored a 2 out. I try 1/3. It comes out to 0. I'm left with 3, 6, -3. I take out my common factor, 3, and I'm left with x squared plus 2x minus 1, which will not factor, so I had to use a quadratic formula on 1, 2, and -1, my a, b, and c, and it comes out to -1 plus or minus radical 2. So these are 2 of my answers, 1/3 and 1/2. Then 21 is listed here. Now, hint on 21, when you find one number, keep using it on your new set of numbers. I think you will find that one number, when you find it, is the same. You have 4 answers that are all the same number. 22, 12, and then -11, then -79, and I forgot a 0 in here when I was working it. 0, then 36. 2 sign changes, so 2 positive numbers, 2 negative numbers. I put 36 over 12, and boy, there's a lot of possibilities here. I was working through this, but I'd forgotten my 0 in here. Should have been 12, -11, -79, and 0, then 36. I tried 1, and so on. And then I found out I left that 0 out, and I tried 3. I put that 0 in, tried 3 again. When I put that 0 in, I'd forgotten, and it comes out to 0 here. So one of my answers is 3. Now I'm using 12, 25, -4, and -12. I try -2 on these new 4 numbers. I use it. I come out with 0. So I've got 2 of my answers, 3 and -2. Now I go with my 12, my 1, and -6, which gives you 12x squared plus 1x minus 6. I happen to factor it but right here you could have used a quadratic formula, but 2/3 and -3/4. This concludes lesson